The recent observations of the Comet C/2025 K1, popularly referred to as the Other Atlas, have captured the attention of astronomers and skywatchers across the world due to its dramatic and visually stunning disintegration in space. What began as a relatively unnoticed comet originating from the icy Oort cloud has now transformed into one of the most fascinating astronomical events of the year. The comet, first detected in May by the Asteroid Terrestrial Impact Last Alert System Atlas, journeyed through the solar system toward its closest point to the Sun, known as perihelion, which occurred on October 8th. At that moment, it passed within just 31 million miles of the Sun, a distance significant enough to put extreme thermal and gravitational pressure on its nucleus. Although astronomers suspected the comet might not survive this intense encounter, initial observations after the perihelion made it appear as though it had emerged intact. For a brief moment, the scientific community believed that C/2025 K1 had withstood the stress of its solar flyby. However, the story took a dramatic turn earlier this month when astronomers noticed an unusual development. The comet began to glow with a rare and striking golden color. This golden hue, visible in both the coma and the tail, sparked widespread curiosity. Comets typically appear bluish, greenish, or white, owing to their mixtures of dust, water vapor, carbon monoxide, and other volatile molecules. But C/2025 K1 stood out immediately. The unusual coloration was attributed to the comet's surprising lack of carbon-bearing molecules, such as cyanide, carbon monoxide, and dicarbon. These molecules usually play a significant role in defining a comet's visible coloration. The deficiency suggested that this comet was chemically unique and possibly one of the most carbon-poor comets ever documented. According to astronomer David Schleicher of the Lowell Observatory, only 2 other comets known to science had an even lower level of these carbon compounds. This rare chemical fingerprint made C/2025 K1 a scientific treasure, offering researchers a chance to study a type of comet rarely encountered in the inner solar system. The golden color also added a visual majesty that caught the attention of astrophotographers across the globe. Among them, Austrian astrophotographer Michael Jaeger took a particular interest in tracking the comet's evolution. In early November, when astronomers noted that the comet began experiencing sudden brightening events, it became clear that something significant was happening. Comets occasionally brighten rapidly when their surfaces crack or outgas large amounts of volatile material, often signaling internal structural stress. These brightness changes in C/2025 K1 were a precursor to what came next, a complete breakup of the nucleus. On November 13th, astronomers confirmed that the comet had broken apart into at least 3 visible fragments. These pieces appeared to drift away from one another gradually, their motion detectable over multiple nights of sky monitoring. The breakup was not entirely unexpected, given that many long-period comets from the Oort cloud are fragile, loosely held together accumulations of ice, dust, and ancient cosmic debris. The intense gravitational tug of the Sun, along with the rapid heating during the perihelion passage, likely caused internal pressure to build until the comet could no longer hold itself together. The sudden release of gas and dust during the breakup event also likely contributed to the unusual golden brightening that had been observed days earlier. Michael Jaeger, who captured a series of detailed images of the comet, released a striking time-lapse animation showing the breakup process over several days, November 12, 14, 18, 19, and 20. In the animation, the fragments appear as separate bright points of light, each trailing its own miniature tail as they drift apart. The imagery reveals the graceful but somber dismantling of the comet as it slowly disperses into space. Jaeger reported that the breakup had been ongoing for at least 2 weeks, and he noted that the 3 main fragments were consistently visible. Later observations revealed a 4th, smaller fragment that had broken away, though this faint component did not appear clearly in the animation. The discovery of multiple fragments suggested that the comet's nucleus may have fractured extensively, possibly into even more pieces too small to be individually detected. The scientific community had hoped to closely examine the comet during its closest approach to Earth on November 25th. This moment would have provided an exceptional opportunity to analyze its composition, structure, and golden coloration with greater clarity using powerful telescopes. For researchers aiming to understand how carbon-poor comets form, evolve, and behave during solar encounters, C/2025 K1 was a rare and valuable case. Unfortunately, the fragmentation of the nucleus now makes these detailed measurements much more difficult. The comet's destabilization means that by the time it reached its nearest point to Earth, its primary mass had already dispersed, diminishing the chances of obtaining clear, meaningful data. Despite this setback, the fragments of the comet remain visible to observers with access to high-quality telescopes or strong binoculars. The broken pieces are currently drifting through the constellation Leo, creating a unique, transient celestial display that will only be visible for a limited period. For amateur skywatchers, this event offers a rare chance to witness the aftermath of a comet's destruction, something that does not happen often on such a visible and dramatic scale. The fragmentation of comets has occurred in the past, such as with Comet Shoemaker-Levy 9 or Comet 73P/Schwarzmann-Wachmann 3, but each event presents different scientific mysteries and visual characteristics. In the case of C/2025 K1, the combination of its golden glow and its sudden breakup makes it one of the most memorable cometary events of recent years. This entire sequence of events highlights the delicate and unpredictable nature of comets, especially those arriving from the distant Oort cloud. These objects spend billions of years in the frozen outer reaches of a solar system, relatively unchanged since the earliest days of planetary formation. When one of them finally makes the long journey inward, it carries with it ancient cosmic material that offers valuable clues about the early solar system. But the same journey that brings them into our view also exposes them to extreme solar forces that can rapidly alter or destroy them. C/2025 K1's sudden disintegration serves as a reminder of how quickly these celestial visitors can transform before our eyes, turning from stable objects into clouds of dust and ice fragments drifting silently in the void. Even though the comet may never again appear in its original form, its brief presence near the Sun and Earth has offered scientists a wealth of information. The golden coloration, in particular, has sparked new discussions about the variety of chemical compositions possible in long-period comets. Its fragmentation has provided data on the structural integrity and behavior of cometary nuclei under thermal stress. And the images captured by astrophotographers like Jaeger will continue to serve as visual documentation for future research, allowing astronomers to study the dynamics of cometary breakup over time. While the comet's death is scientifically valuable, it is also visually and emotionally moving. There's something almost poetic about watching a celestial body, formed billions of years ago and traveling for countless millennia, finally succumb to the forces of the inner solar system. Its golden glow, the shimmering tail, the drifting fragments, all of these elements combine into a display that reminds us of the beauty and fragility of cosmic objects. In space, death truly can be a beautiful phenomenon, and C/2025 K1 has demonstrated this in a way few comets ever have.